Uh, Welcome everyone. Thanks for joining with us in our 21st webinar and good morning. And today we are going to see about today we are going to talk about how we can achieve higher availability in PostgreSQL. Okay, so it will be definitely helpful if you are having or if you are using PostgreSQL in your production servers. And it's about me, myself, Aakash. I am working in MyDBs for the last 5 years, and I am a database reliability engineer. I have worked in MySQL and PostgreSQL database, also a certified database professional, and also I have done many technical speaks. Okay, written a few blogs as well. And this is about our company Mydbops, which is founded in 2016 by a two-member. Okay, which we actually focus on providing services on top databases like MySQL, MariaDB, MongoDB, and PostgreSQL. So when we started, it was just two members. Now we have grown and we are more than 90 plus members. So far, we have assisted 500 plus customers across the world. Also, we are proud to say we are certified AWS partner, ISO and PC certified organization also. And these are the two types of services that we are providing in MyDBOps. One is database consulting services and the database managed services. We consulting services which focuses on short-term engagement and which mostly focuses on particular kind of issues. Okay, taking audit or solving particular issues. Whereas managed database services is completely take care of database activities like monitoring with 24 hours or monitoring database active database team support. So right now we are giving support for MySQL, MariaDB, MongoDB, and Postgres also. Okay, let's get into our topic. Today we are going to discuss about high availability. Okay, so before getting to high availability, we will just have words about basic concepts of HA. Okay, and what are the HA options natively we have in PostgreSQL? So example, streaming replication and logical replication. And what are the open source tools to help for to achieve HA in PostgreSQL? And finally, we will have a small demo on that. Okay, so first concepts of HA. So as we know, HA is a basic definition of HA, which means that even when we are losing our hardware or software of a particular server, we should be able to run our business. Okay, that is, we say it is a HA. And these are the very key principles. First one is redundancy. So it means that avoiding single point of failure. Okay. Let's say you are running your production server with a single server. Production on a single server means what means there are chances we may affected by single point of failure. So redundancy means having multiple copies of the same database. That is called redundancy. Okay. So if you are going to achieve HA, then that is the first part. We need to maintain redundancy of our database. And second one should be automatic failover. Okay. So now next part is we will have redundancy, but in case if you are down, right, there should be automated way to perform failover. If you are definitely going to manual means there are a lot of issues come and we can't meet our SLAs. Definitely, we should have automated failover and monitoring. It is the most important thing because our cluster should be aware of the each other every cluster status. So monitoring also should be done, and load balancing is of course needed. We are having multiple servers and we can distribute our load across the server. Even if we are fail or we are getting fail alerts on one server, we should be able to serve the traffic with the remaining server. That is only possible with load balancing. And final thing is scalability. And one more advantage of going HA is we can easily scale our read traffic to either we can easily scale up or scale down based on our needs. This is about the HA. And we can talk about planned and unplanned downtimes. Okay, planned downtime means mostly, example, if we are going to have some kind of patch activity or maintenance activity, that we can say it as a planned downtime. Mostly, we will be aware of this activity. Okay, and what we will do, we will get do that activity in a particular time, and we will enable downtime notification on our application window. We can say maintenance window. That's it. Okay. But whereas in unplanned downtime, right, it means that whereas it is unexpected for us, maybe some hardware or software failures, or else some kind of resource saturation. So these kind of things will cause us unplanned downtime. Okay. So if we are going to build a HA solution, it should be either handle both planned and unplanned downtime. Okay. If we are going to do planned downtime, our HA should allow us to do our maintenance without being down. That's our HA should focus on that. And of course, for the unplanned downtime, it should support automated failover, load balancing, everything. And another important thing that is called RPO, recovery point objective. Okay, so every organization or every server we should define RPO. So it means that maximum acceptable amount of data that we can lose. Okay, let's say you are facing some server crash. Okay, you should have some limit. Okay, this I can lose this much data. For example, if you are having some RPO of 2 hours, means in case of any worst case scenario, you can lose 2 hours of data. Okay. So, and it should not impact your business or customer information, anything. Okay, that is called, we need to define RPO. Okay, mostly 2 hours is very high, but it will be like some 1 minute or 30 seconds will be there. So how we can improve the better RPO means you should have regular backups. Okay, by having regular backups, you can reduce the, or you can improve your RPO. Okay, not only the database backup, it should be also have the wall file backup as well in PostgreSQL. If you are doing only database backup, we can definitely meet our RPO. Okay, so what we should do means we should also track our wall file backups regularly, then only we can perform point in time recovery. That is very important. And most popular thing is continuous replication. Okay, that by having some replicas, we can definitely have better RPO. And recovery time objective, it is like how much downtime you can afford in case of a disaster. Okay, let's say you are losing a server, how much time you can be down and how far it won't be impact your business. Okay, that is called RTO. Let's say your downtime, you can your RTO is of 2 hours, means you can tolerate downtime and you can do your business won't be affected until the 2 hours. That is called RTO. Okay. How we can have better RTO? That means that you can have load balancing. Okay. Let's say you are having 3 servers and you should have proper load balancing. Then only if you are losing one server, then only you can also serve your traffic by having the by using the other 2 servers. That is very important, the load balancing and automated failover. Okay. If your primary is going down, you should have automated failover that should be reliable and immediately promote to the any other valid primary to the new master. That is very important. So by achieving this, you should have definitely have better RTO. And another term is mean time to recover. It means that average amount of time to take care to recover from a failure. Okay. Again, if you are saying you are getting your hardware failure is there. Okay, how much time you are going to take to fix that? Okay, so it is the sum of detect and diagnose and the fix. Okay, how much time you are going to taking to detect the issue, how much time you are going to diagnose it, and how long we are going to take time for the fix the same. Okay, this is the combination of MTTR. And how to have better MTTR means simple. We should have monitoring. Okay, it will help to reduce your tool detection time. Okay, if you have proper monitoring, you will get failure notification immediately, and you can you can reduce your monitoring detection time. And having observability tools like PMM and all help you to reduce the diagnosis time. Okay, so this by achieving this, you can reduce your overall MTTR. And geography recovery objective. Okay, so it means that maximum allowable time it takes to recover a database DCT level disaster. Okay, consider you are having one DC in Mumbai and another DC in Bangalore. Okay, you are losing your main DC Mumbai, means you can serve your traffic by having traffic on the Bangalore DC. Okay, so it means that GRO means that how long it will take to recover the main DC Mumbai back to life. Okay, that is called GRO, right? Geography recovery time objective. Okay. So if you are going to build a HA, you should have all these stats available. Okay, then you can decide what kind of hierarchy architecture you can use. So once you are ready with that, let's you can calculate your availability. Okay, how much percentage you want to be available. Okay, it completely depends on the business and its criticality. How much you are giving SLAs to your customer. Okay, if you are 99%. You need to be up for a given year, you can have 7 hours downtime per month. Okay, it means that your architecture can be very simple. You can have one master and a replica. Even if you are down with a master, you can just manually promote your replica because you have 7 hours of downtime per month. But at the same time, if you want to achieve 5 nines, that is 99.999%, you will have only 26 seconds downtime. Okay, it is very low. By having just a master and a replica architecture, you can definitely achieve a result within 26 seconds. So you need to define your availability calculation first, and then you can proceed. Okay, so now we have seen the general terms of HA. Now we will see what are the HA availability options natively available in PostgreSQL. Okay, so we have two options widely which is used. One is streaming replication, and the another one is logical replication. Okay. There are other options like disk level replication is also available, but it is not natively available in PostgreSQL, and it is expensive to do that. Okay, so let's focus on what we can achieve on database level that is natively and freely available. Okay, before getting into streaming and logical replication in detail, we will just have a glance about replication history, how it is evolved in PostgreSQL. For example, we can say before the 7, right, PostgreSQL version 7, we don't have any native replication solutions in PostgreSQL. Okay, so we need to believe on some third-party tools like Sloany, Bookwader. Okay, these are trigger-based things, trigger-based replication that whatever we are doing, right, it helps to do at that time. Okay. And then it is a PostgreSQL team understand the importance of replication, and they have came up with a feature in 8 that is called log shipping. Okay, that is the basic of the one which we are currently using, streaming replication. Then it is evolved. The log shipping is evolved. That is, we are calling streaming replication, the one which we are currently widely using. So everyone in PostgreSQL definitely know about streaming replication. And then it is evolved to logical replication. Also, right, we have two types of standards: warm standby or standby. Previously, there is only thing called warm standby. Warm standby means that we can have a replica, but we can only use the replica for failover. We can't run any kind of read queries will be there because it will be in always recovery mode. We can't run any kind of read queries. We can't actually use it for anything. Okay, only for failover purpose. Then in 9, they have introduced something called hot standby. Okay, hot standby, by using that feature, we are able to run our read queries or reporting queries in replicas also. So that is one of the major changes happen. And this is the timeline. Okay, so how the replication is evolved. In 7.0, there is no future of replication. Okay, it is completely 0. We need to rely on third-party tools. And in 8.0, log shipping was introduced. That is called point-in-time recovery. Earlier, wall files is only used for crash. Now 8.0, they have made changes to support replication as well. Okay, so and then in 9.0, right, it is evolved to streaming replication. And as I mentioned earlier, it was only warm standby. Now it is changed to hot standby. So we can use our replicas for read queries from 9 onwards. And in the 9 series, right, there are a lot of things were introduced to enhance the streaming replication. That is PG based backup. Okay, earlier there is no concept of PG based backup. In 8.7, if you want to have replication, you need to definitely shut down your database and out sync it and then start up. Okay, but active or active physical backup is available only from the 9.7 only. And then it also started to support synchronous replication. Earlier it was only support have for async, then it is having for sync, and cascading replication as well. Cascading replication means let's say you are having A as master and B your replica, you can have another replica as C which will fall under B. Okay, A will fall to B and B will fall to C. That is called cascading replication. That is also available from 9.7. Okay. And in 10, there is a concept called logical replication is evolved. And then after that, there is not much greater changes, but lot of enhancement being made for logical and streaming replication in 11, 12, 13. Okay, in example, we can say in 13, logical replication started to support partition tables as well. Okay. So now get into detail of available things in PostgreSQL. So first one is log shipping. Mostly very rare case we are using this option now because mostly we are evolved to use streaming replication, but it is still good to know what is log shipping. It is actually introduced in PostgreSQL 8.0. Okay, it is replication based on the wall file archival. Okay, what we need to do, we need to enter our archival command on the primary. What actually it will do means whenever any log file, wall file is rotating, it will archive the data to the archive location. And we need to enter our restore command on the standby. Okay, restore command needs to fetch the particular wall file and apply on the standby. Okay, so it is called file-based replication. Why we are saying file-based replication means whenever we are completely written our wall file of 16 MB, then only it will be archived, then only it will be applied on the uh, standby. Okay, so definitely always we will be having lag of one file minimum in our replica. So this is the architecture diagram of log shipping. Okay, we will be having primary server. So by default, we know that all the wall files will be in the pgxlog or pgwall. Okay, so by using the archive command, we will move that wall file to either a cloud or NFS storage. Okay, in the standby, by using the restore command, we will retrieve the wall file and apply on it. Okay, so this is the mechanism of the log shipping. So what are the advantages here is it is definitely a lower network overhead. Here you can see we don't need any direct connection between primary and standby server. Okay, it simply means that for the use case like you are having one DC on one region and another DC on another region, so both are having very longer distance and you don't have the possibility of connectivity means, then definitely you can use this method. Okay, so you don't need any direct connection method here. You can just save it somewhere and you can lately download it on the standby server. That is one of the greatest advantage of log shipping. And yes, of course, it is works fine with the older version. And if you are using 8, I hope you won't use 8 anymore. But if still you are using 8, you have only this option. And no real-time replication. Yes, disadvantage is no real-time application. As I told earlier, it is a file-based replication. So always we will be having a delay of one file. Okay, so it is not good to, if you are, there are chances we might lose some data. That is called, we can understand from no real-time replication. And of course, it is not possible to support synchronous mode in this one because we are archiving wall and then only it will apply. So it is not possible to achieve on this mode, synchronous replication. Now let's move to the next one, that is streaming replication. We can say it as an evolution of the log shipping. It is actually started in PostgreSQL 9, and what it will be, it will stream the wall files directly to the standby. Earlier we saved it somewhere and replica needs to fetch it. Now we will just stream the wall files directly to the standby without any intermediate phase. That is called streaming replication. What we need to do, we need to have primary connection info in recovery config area. Now it is merged with PostgreSQL.conf itself. You can have primary conf info. You will have the host username and password of the primary server. By using that, replica will connect to your primary and get the record wall files. Okay. It is block-based replication. Earlier it was file-based, so we need to send file by file. Now it will send each block changes. So there are minimal chances of replication there, and also there are minimal chances of data loss as well. This is the architecture diagram of the streaming replication. Here one is primary and another one is secondary. We are writing something on primary, and each and every wall records will be processed by a process called wall sender, which will be always running on the primary. Okay, and it will be transmitted over the network to the wall receiver process, which is running on the secondary server. Wall receiver process will run it and apply the changes to the secondary. So this is the architecture diagram of the streaming replication. Advantages, yes, supports real-time replication. We don't need to wait for one file to complete. Whenever you are making commits, it will be immediately available in the replica. Okay, you are having some scenario, you will write something and you will immediately read it on replica commits. Then definitely you can use streaming replication, and it supports synchronous replication as well. And this is the only one we can reliably believe for failover. Okay, because data loss will be minimal, so we can use for failover of this server. And it only thing is it requires direct connectivity between the two servers. So this is the one. We need some network connection between primary and secondary servers. If there is no possibility of network connection, then we can't achieve this architecture. And next one is logical replication, which is available from PostgreSQL 10. We can say it is a source server. We can say in logical replication as publication. In publication, we will be having tables, table 1, table 2. We need to define what are the tables we are going to replicate. And on publisher side, right, we will be having status, sorry, the subscription side, we will have the connection details of the primary server. Okay, this is the diagram. It will be mostly similar to the streaming replication. Here only difference is vault senders will decode the vault file and send it to the replicas logical messages instead of the vault byte level changes or block level changes, we can say. That is one of the changes in this architecture. Advantage is granularity in replicating data. So whereas in streaming replication, problem is we can have exact copy of our primary, okay, in our replicas. If your primary is having 1 TB means you should have exact directory structure, exact data, everything should be there. But in logical replication, we can even replicate the very small tables or whatever we need only record. That is called granularity. And in streaming replication, we can't write anything on our replica because it will be on recovery mode. But with the logical replication, definitely we can write on replicas as well. And replicate across different versions is possible with the logical replication. Let's say, and also it can be used for migration purposes. So you are using PostgreSQL 11, and if you want to configure replication between PostgreSQL 11 and PostgreSQL 15 means it is possible with the logical replication. But you can't achieve the same with streaming replication because the versions should be same, major versions. And disadvantage is DDL is won't supported. So if you are performing any DDL, it won't be replicated and not suitable for failover. As I mentioned, it won't be the exact copy of your primary. It will have very minimal or only the record data of what we wanted. So we can't use it as an exact reason for failover. That is one of the drawback of this one. And bit high overload. When compared to logical streaming replication, our vault center process needs to have some more CPU and memory to perform logical replication. So that is one of the disadvantages. Okay, now so far we have seen the three methods: log shipping, streaming replication, and logical replication. Now, which replication suits such a? Okay, so let's say you are going to have hierarchy in your information. You need to define which one you need. Okay. The answer is very simple. For hierarchy, you can blindly choose streaming replication because it supports real-time replication, whereas log stripping won't give that, and it gives you consistent data. Okay, why it is consistent means if you are going for logical replication, the data structure will be different and it won't be the exact copy. But in streaming replication, it will be the same like your primary, so you can easily use it for your failover purpose. And it supports synchronous replication also. So by having this feature, you can easily use streaming replication for your HA setup. Okay, now next question may arise. Okay, by having only streaming replication, is it enough to have good RTO? The answer is no. However, let's say you are setting up your architecture with a primary and 4 replicas. Okay, you will start writing your applications on your primary server and reads will be pointed to your replica. Consider your primary is going down. Okay, just a scenario, it is getting crashed, okay, and it is not coming up. Now you need to promote any of your replica to the new primary. Okay. So this is called we will have very bad RTO. Why means we need to manually interfere here, and we need to check what is the latest. What is the which replica is most synced with the primary, and we need to manually promote that. Okay, it will take really a lot of time, and also there are chances of getting errors. Okay, so these are the problems, existing problems by having only streaming replication in your topology. Okay. So no leader promotion during failover. There is no communication between the cluster. Okay, if your primary goes down, there is no chances of failover on the server, and no capability of the monitoring the cluster status. Yes, each server doesn't aware of the other servers status of the other servers, and no automated process to add the failed leader back to the cluster. Okay, if your primary goes down and it is come back after some time, you need to manually add it. There is no automated way to add it as a back as a replica. And it is very difficult to do manual switchover. If you are having lot of replicas, you need to do the failover and you need to point all your other replicas to the new master. It will take lot of time. And as it requires manual intervention, there are chances of making mistakes. Okay, there are high chances we can make mistakes, or we may promote some wrong replica at the hurry. These are the problems that we can face with the existing streaming replication. Okay. How we can overcome this problem with the existing streaming replication? So that is very important one. By natively we can't do that. PostgreSQL doesn't support any native feature to do that. But by using third-party tools, okay, we can definitely achieve that one. That is called Patroni, Replication, PG autofailover. These are the all things available. By having these tools, you will be able to overcome all these issues. We can use anything. Here we will discuss about Patroni, but you can refer to the documentation which one might suit your needs, and you can use that. Okay. And why we are discussing Patroni means it is the most popular hierarchy framework which is used in PostgreSQL community, and it is actually developed and giving some bug fixes in the open source community, and also it is having very more stars when compared with the others. That is the one. So we are choosing this one. We will discuss on this. Patroni is having continuous monitoring. These are some of the features of Patroni. Patroni is having continuous monitoring of the each and every server status. If in any case any other server goes down, it will be aware of it. Not like the earlier streaming replication. And it supports automated failover. If our primary goes down, it will promote any of the valid replica to the new primary and point all of the replicas to the new primary. There is no manual intervention needed. Everything will be taken care by automated way. And it is very easy to add or remove any node. Let's say you have some peak sale coming up and you need to add any other nodes. You can just install Patroni there and you can just start this Patroni. It will automatically take the backup from the current server and it will build the new replica. You don't need to do anything. And once the sale's over, you can just simply shut it down and remove it from the cluster. So that is one of the things. And it will join back the node. In case you are losing one of your replica, after some time, if it is available means it will automatically join back the node to the cluster. If that is not possible using PG event, it will completely take the full backup and it will automatically, no manual intervention needed here as well. And other than this, it also supports manual failover and switchover. If you would like to do any kind of manual switchover or failover, that is also possible here. And also if you want to pause the failover for a while, let's say you are going to do some scheduled maintenance, okay, in a downtime period, and you don't want to do any kind of failover at that time by Patroni means we can just simply pause the Patroni for the particular time and you can perform your activity. That is one of the advantage. And another thing is called Patroni CTL, which is a CLI. That is very good CLI that will be offer a lot of functionalities to do all these things in the Patroni. This is the basic HA setup for Patroni. What we need to do, we need to have database server install PostgreSQL of same version across all the database, and it should have Patroni installed in it. And we will be having etcd where distribution data store will be, the configurations will be stored on the etcd. Okay. Patroni won't communicate with each other directly. Patroni will send the data to the etcd server and it will communicate only through the etcd. So this is the general architecture diagram of the Patroni and its working. Okay, so now we will see how we can build a Patroni in any processor. So to do Patroni setup, you should have etcd. This is for distribution configuration store. As I mentioned in the previous diagram, Patroni won't communicate with each other. You should have something called distribution configuration store. Okay. If you don't want etcd, you can use some other thing called Jupyter and everything. You can use that. Okay, but etcd is the most popular one people use. And definitely we should have installed Patroni on all the database servers, and PostgreSQL should be installed as well. And HA proxy, if you want to have load balancing, you can use the HA proxy. If you don't want load balancing, your application can handle that means you can avoid the HA proxy setup. Okay, so this is the Patroni setup we are going to achieve now. So what is the thing is we are having 3 nodes, node 1, node 2, node 3. And we have installed Patroni on node 1, node 2, node 3, and databases as well. etcd is also installed on all the 3 servers. And we are having another separate server that is for HA proxy. HA proxy is running on that, and it is configured on 2 ports, if you are hitting 5432, it will hit the patron, will hit the writer directly. Okay, so you can use your read-write applications to hit 5432, and for read-only applications, you can use 5433. It will only hit the replicas. By using this, you can avoid your heavy reporting queries hitting to the primary server. So first, let's see about how we can set up etcd. So on node 1, you can just install etcd with the app to get installed. If you are using yum or some other thing, you can definitely use that. And once you are installed, just go to the configuration file which falls on etcd default etcd, and then you can just simply use this config. Okay, what it is saying is you should have etcd name. You should mention your node name and the initial cluster name. You can mention your IPs and cluster token. You can give some unique name here. And here only important thing you should be aware is cluster type. Here it is new. Okay. On the next servers, we will be using existing. But while starting the first server, you should have mentioned as new. Remaining everywhere, you can use your same IPs. And once you are making these changes, you can just start your etcd in your cluster. Now one server is started. Just follow the same on node 2 and node 3 as well. Only difference is on the cluster state, you need to use existing. On the first server, you have used the etcd new. On the next set of servers, you need to use existing because the cluster is already formed. That is called state of the cluster. So once it is done on node 2 and node 3, you can simply start it. Now etcd forms a cluster. Node 1, node 2, node 3 connected with each other by etcd. To check the status of etcd, you can run this on any of the server in node 1, node 2, node 3. You will get the status like this. So leader means the active leader, and remaining are the followers of etcd. Once we are done with etcd, we can move to the next one, that is PostgreSQL. Just try to keep same versions. If you are having different major versions, we will get an error. And ports, of course, these are the ports needs to be open. 5432, 2379, 2380 should be open between the database servers. And by default, if you are using yum or app, it will initialize a database. Okay. As we are using Patroni, we can use the Patroni to initialize it. So just clean up the database once you have installed on all the 3 servers. Once we are done with the database, we can just go to Patroni, apt install Patroni is the one, and the Patroni config file will be there. And we couldn't attach the Patroni config here because it is too long, so I will show it later if possible. And we need to just repeat the same on the other 2 nodes, and we can start the Patroni. Now, once you are done with the Patroni, you can just see Patroni CTL list command will show the status of the Patroni cluster. Okay, it will have the cluster name and members of the member name, post details, and role. If the role is empty, means it is replica. If it is leader, means it is the current primary asset. And state will be running. If you are having any other thing running, means there should be some error. You need to check the error log, maybe unknown or error, something will be there. And lag in MB. If there are replicas, it will show if there is any lag in there. So that's all about the setup. Now let's have a small demo on it. So to have a demo, we have just made our setup, made this exact setup in our testing environment. Okay. So we are having 3 servers, node 1, node 2, node 3, and a HA proxy server. So let me share. So in this tab, you can see 3 sessions will be there. First one is node 1, second one is node 2, third one is node 3. And in this tab, there are 2 sessions there. On the left, it is the HA proxy. It is actually hitting on the primary. And on the right, it is the replica. It is actually hitting the replica port. Okay. So let's see the first scenario. So we are going to just discuss the failure scenarios of Patroni. Okay. Where are the cases Patroni can help you? Now I'm going to shut down the replica. Let me check which is there. Okay, so I have 2 replicas, node 2, node 3. Let me shut down the node 3. So you can see I'm shutting down the Patroni. if I shut down the Postgres, what it will happen means Patroni will start it again. If you know about MySQL means MySQL D will be running. If MySQL D crashes, MySQL D save will automatically start it. Okay. That's the same kind of thing. So that's why I'm stopping the Patroni itself here. If okay, you could see it is stopped, and start it on same justice. Okay, now you can see we are hitting both the IPs 168 and 123 in round robin fashion as per the HA proxy. Now I am shutting down the Patroni. You can see we got one failure. After that, we are back to live with the same replica. So at least we just got 2 seconds failure of a particular server and we are back. So by having this kind of architecture, we can completely avoid read replica issues. So let's start it back and we'll go to the next one. Okay, fine. So next one is now we will try to shut down the primary itself. See to see what happened actually. So node 1 is my primary. I'm going to shut down my node 1. Okay. So here you can see we are down now for 1 second, 2 second. Within third second, we are pointed to the new replica. So here my RTO is just 2 seconds. I am back alive within. It's the most worst case that we are doing for the replica, and also in master and in replica also you can see earlier it was distributed to 2 sessions. Now it is only serving the traffic by using the only one replica because another one is promoted to the master. Let's check the status to see the what is the current master. Okay, current master is no to miss current master. Let me start the server back. Okay, now you can see it will be added as a replica without any manual interventions. And next is, let's say now so far we have done very safe shutdowns. Now we will see what happened in case of crash. Okay, let's say some OM killer or something is happened. What will happen? Okay, this is my current master. Let me kill the Postgres process here. Okay, this is my PostgreSQL process. I'm going to kill it with a -9. Okay, done. You could see we are down for a second, but if you closely monitor, our IP hasn't changed. Earlier it was 168, now also it was 168. The reason is once we have killed it, Patroni will try to start the process. Okay, Patroni will try to start the process. In case if it is unable to start it, then only it will perform the failover. If it is able to start it, it won't do that. So currently the same happened. It will try to start it, but actually able to start that, then actually it avoided the failover. That's what it is happened. So we were down for a second and we are back up now. So now we will see the next scenario. Patroni crash itself. We will just crash the Patroni itself. So still it is my new primary. I'm going to kill the Patroni here. Okay, it is my Patroni ID. Okay, done. Okay, you can see we are down now. When with other cases, right, we are down for long. Mostly other cases we are down for 1 to 3 seconds. Now we are more than for 10 seconds. We are still down because it is one of the worst case, crashing the Patroni itself. Actually, yeah. Okay, we are back now. Okay, so earlier it is 168. Now we have moved to 114. And also read replica is also adjusted to serve the traffic. Now let me start the Patroni here. Okay. Yeah, it is back. So it will be added as a replica, and my read queries are served to have the traffic on the new server as well. And other thing is, other than these kind of clusters, we have option for manual switchover as well. If you have some kind of duty and you need to do some kind of switchover, means definitely it will be helpful. Okay, so it is having a lot of features. We can use this one to do switchover. Okay, so it is saying it is my current master. Yes, node 1 is my current master. Which one you want to promote? Okay, let me promote node 2. Okay, when you want to promote, if you want to do now, you can do, or else you can schedule the time as well. I will do it now. Okay, it is asking the final confirmation. Once we are given, we will promote it. Okay, during promotion, we are failed for a second, and then we are back live. Yeah, that's it. Okay, other than this, in case if you are losing a replica, and also it will automatically take the base backup. So now let's go to the next one, that is mostly frequently asked questions when we are dealing with a customer who would like to have some kind of higher level architecture. These are the most common questions we will get from. The first thing is, will it support logical replication? Yes, of course, we can use the logical replication. You are having a cluster, means you can have logical replica server behind your master. Okay, so that also supports, and can we ignore particular node from failover? Okay, so you are having some 3 servers, and one server is having low spec or it is using for some other purpose. We can completely avoid the particular node from getting failover, involving failover, or else in load balancing also. Okay, we have options for that in Patroni, that is called tags. Okay. So by using that option, we can completely ignore that. And the final one and very important popular question to us is, can we convert standalone to Patroni? Yes, of course we can convert, and we can able to do that without downtime. Okay. So if you are having some standalone master, or else standalone, or else having just a primary and replica, means without downtime, we can easily convert that to a Patroni cluster. Yeah, that's all. Thank you.